Alright, welcome back, and sorry for missing the whole quarter ones of 2026. I was drastically locked into my life and a lot of things coming in. Yep, that was lack on its of my missings in the 2026 Q1. Let's solve the Leetcode problem. So the Leetcode problem is a maximum numbers of jumps to reach the last index. So we are given in 0 index array numbers of n integers and one integer target. So we are initially positioned at the index 0. In one step, we can jump from index 1 to any index j, such that there's a few conditions we need to consider. So the index that we would like to jump should be greater than, not the greater than, must be greater than the index and must be less than the total number of numbers and index, and it should also be the in between of the targets, plus or minus whatever is come. We have to return the maximum number of gems that we could reach. So let's try to understand the problem a little bit more. Let's consider there is the HTML1 given in here. So we can consider the two approach. Initially, we are at the here. And then what we want to do, let's call and write a little bit in here. Let's go, we have target is 2. So according to the HTML1, oh gosh, all right. Target is 2. Now we are given like nums 1, 3, 6, 4, 1, and 2. So originally our index is here. So what we would like to do is we want to switch from the index 0 till the end of the index. How many gems we could maximize in between the one iteration? So by saying that, what we can say is I am currently at the index 0. Okay, let's try to add an index for more clarity. Let's consider 0, 1, 2, okay, 1, 2, 3, 4, 5. Alright, cool. There we go. I should have split this out. Alright, that's the target that we have. And that is the index that we know. Let's change the index color into something else. Alright, cool. So we can jump from index 0 by using the keywords called like 1. So to jump that, we have to check the value of the index that we want to switch is a 3. Okay, let's write it through. 3 minus 1, which is 2, and that is exactly the same as the target 2, which is highlighted in here. So we need to keep in mind that every time we want to jump to the specific number, we should consider like what is the number we can jump. But that is not just the one number. We could jump to all the possible area. Like instead of like jump to the index 1, we can jump to the index. Why don't we jump to the index 2? So that's a great question. But we're gonna simply jump it. If you want to jump to the index 2, that will be 6 minus 1, and the result will be 5, which is not in the range of the target plus or minus. So the same for the index 3. 4 minus 1 is 3. 1 minus 1 is index 1 minus 1 is 0, and 2 minus 1 is 1. So only 2 point is valid in here. How can you notice that 2 points valid in here? So this one, and this one. But if we directly jump to the end of the array, that could literally cut our integer number of the maximum jump will be 1. That is not the value what we want. What we want is how much maximize we can get it. So by saying that, so we're gonna jump to the here, there, and then let's consider we have one variable called answer in here, 1. So speaking of which, we're gonna jump to the next approach. Okay, so from 3 we have a lot of options to jump. So what we could consider is, okay, I'm gonna jump to the index 2, so 6 minus 3, that is 3, which is not in the range of -2 to +2, so I'm not able to choose that. And then we're gonna consider like index 3, that is in the range of 4 minus 3 is +1, so that is in the range of -2 to +2, so that is valid. 3 minus 1 is 2, that is valid. And then 2 minus 3, that is -1, that is stay in the range. Cool. And then what we're gonna choose is, maybe we should choose the, according to the estimate, we're gonna choose the index 3. So I'm gonna increment my answers to 2 because we have jumped 2 times, and then we are here. So from here, I have 2 options. Should I jump to the next index 4 or index 5? So 4 minus 1 is technically +3, that is not in the range of -2 to +2. So we decided to choose to switch to the less index directly, and then that is how we get the answers 3 in here. So it is also mentioned that if we cannot reach to the end of the index, we can directly return the -1. So by seeing the pattern of this problem, that's definitely the dynamic programming. Let's consider like count for nums.count, and then we're gonna use the dynamic programming array. Let's call like db. According to the Swift, we're gonna just use the repeating of -1. Count will be the count. So what I'm gonna do is I'm gonna use the index in each number we could find till the end of the index. So what I'm going to iterate it through is like from nums to the, from index 0 to the index 1, 2, 3, 4, 5. That's what I'm doing here. And then we're gonna need the one base case in here, because even though if you want to return the db of count -1, which is a less integer index, if I have to define the base case, maybe that is the best idea, is to put the 0 in the dynamic programming of first index. So what I could do is, if index is -1, I'm gonna continue to the next step. So here's where the most important stuff come in. What I can do is, maybe let's call like inner index. That is a weird variable naming, but I don't have any option at the moment because I have not doing the Leetcode properly for the 1 quarter. Just trying to solve the problem and submit. And then that would be the index +1 to the end of the count. So here's where we can do the difference. So let's consider like different will be the nums of inner index. That would be the j in here. Let's call this as j. Negative nums of index. So we should receive like plus or minus. Maybe there's a one that we can do in Swift. Just use the absolute function. And then we can just compare it. If different is greater than or should be the less than or equal to target. So that is what the value that we want. Inner index will be the we can just directly define the value. So I was wondering we should define the db of inner index or db of index plus 1. We can get the max in here. Yeah, we can definitely get the max in here. Let's try to run through it. That solved the problem or not. Yeah, I think the space complexity for this will be the O of n, since we only use the 1 dB array, and the time complexity will be O of n squared because we have a 2 nested for loop. Yep, that's pretty much for it, and then see you in the next one. Bye. Wait, before saying bye, I'm gonna definitely confirm that my space complexity and time complexity are correct. Okay, time complexity of O n squared and then space complexity of O n. Alright, that's pretty much usage of AI in Leetcode. Alright, surely see you in the next one. Bye.